Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to this Techstrong learning experience brought to you by DevOps.com. My name is Cody, and I'm the host of Techstrong Learning, and we have an exciting program ahead. Before we get things started, I do have just a couple of housekeeping notes to cover. Today's session is being recorded, so if you miss any of our discussion, or perhaps you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. Now, if you'd like to engage with us today, you can do so using some options on the right side of your screen. The first of which is going to be the chat tab. And I'd like you to start warming that up for us right now by letting us know from where you are tuning in. To the right of the chat tab, you'll notice it says Q&A. For any questions that you have for our presenters today, we'd like you to go ahead and send them in there, and we will try to bring them into the fold as we get them. So just feel free to chime in with any thoughts you may have. We do have some handouts that are available for you over there in the handouts tab, so feel free to jump over there and grab those. And of course, before we close out, we are giving away 4 $25 Amazon gift cards. Be sure to stick around for the duration of our program today. So our topic today is the impact of low-code, no-code on DevOps. And I'm joined by Venkat Thiruvengodam, CEO and founder at Duplo Cloud, and our very own Mike Vizard, who's Chief Content Officer at Techstrong Group. So Venkat, thank you so much for joining us today on Techstrong Learning. Mike, do you want to go ahead and get this thing rolling?
Yeah, absolutely. Thank you, Cody. Venkat, let's jump in with some high-level stuff and then work our way through. And maybe this is just me, but I feel like we started out doing a lot of infrastructure as code using various tools that operated at a fairly low level. And we were like, wow, this is great. We can push more stuff left towards developers and the world's going to be a better place. But it seems like there's a lot of components on the back end, right? There's containers now and all kinds of different infrastructure services, and it's kind of complicated. So from your perspective, where are we on this journey? And secondarily, while you're doing that, tell people a little bit about what you guys do, because I'm not sure everybody watching this knows who you guys are. So, weave your answer in with some insights about you guys, and we'll start from there.
Yeah, thanks. Thanks, Mike. I'm Venkat. I'm the CEO for Duplo Cloud. We are in the DevOps automation space. We ourselves do a lot of low code, no code stuff. Coming to the infrastructure as a code and so on. So if you see, I think infrastructure is going through the same evolution that mainstream programming went through. So in that sense, I think if I were to walk you through, it's not a surprise. So for example, if you look at mainstream programming, we started sort of like let's say C or like even assembly, and then we went on to higher languages like object-oriented programming with C++. Then came managed languages like C#, Java, and so on, and then came the services like Kafka and stuff, and finally a low code, no code in terms of application development. We are doing the exact same thing in infrastructure as well. So much of maybe the early 2000s was about like primarily bash scripts and so on. Then came so to speak, your Chef and Puppets, and then came infrastructure as a code. So, and then we progressively, we are making progress over there. So I think if you were to just compare it, I would basically say we are in a world where we are still largely, if I were to compare, more like C++, Java-ish kind of a thing. With respect to infrastructure as a code. And then I think it's about time that we sort of like take to the next level and go to the low code, no code. So infrastructure as a code is just like any other programming, is just catching up.
Who's using these tools? And I'm asking the question because a lot of professional developers I know have a certain amount of, at least they did historically, bias against low code, no code tools. But is that changing as they kind of see all the other guys coming up behind them going, hey, I'm doing 10 times as much because I'm not using this low level stuff?
Yeah, I think for one, what I've seen is that, there are really two disciplines here that we're talking about, right? So we are talking about the DevOps discipline, right, which is people who are operators, security professionals, and so on. And then there are actual developers. So when you talk about infrastructure as a code, like you would expect like developers who do programming all the time would adopt it a lot more, while DevOps, who sometimes can even start from an IT background, would tend to catch up. But It's actually exactly the opposite. Like infrastructure as a code is like really popular with DevOps engineers, right? But whereas I think what's happening is that the developers have enough of their own stuff to write code, develop PR and stuff. They don't want to context switch in their minds and then go and learn another set of programming language. And it's not just about programming language. Infrastructure as a code is just maybe another DSL or a language, but you really need to know operational details. You need to be an operator, you need to be a security person, you need to be a compliance person. Only if you have these subject matter expertise, infrastructure as a code is of any use to you. And because developers don't have that knowledge, it's harder for them to adopt infrastructure as a code. Not that they cannot program, of course they can program, whereas the DevOps people can do that better. Because they have all the background, it's easier to catch up on the programming front. That's one. So that's why, like, for example, who's using and who's not using, that's sort of an answer for that. But now what is needed is that developers don't want to sort of wait behind DevOps engineers in order to get their deployments going, test their code, roll it out to production, maintain, upgrade, and all that kind of stuff. So now in order to do that, they have to operate their infrastructure. So what do? They don't have these skill sets. Infrastructure as a code to combine with this is hard. So that's where low code, no code tools come in, wherein that subject matter expertise in terms of security, compliance, operation is abstracted out for them, and engineers can go to these platforms and just build and operate their infrastructure without having the subject matter expertise. Low code, no code is in sort of a manifestation of this solution.
On the other end of the spectrum, are we also seeing traditional IT administrators getting more involved? Because, historically, as one guy joked, I said, what do you think about all this infrastructure as code stuff? He says, it's great, but if I knew how to code, I would have been a developer in the first place. So, is
Right.
low code, no code going to make infrastructure as code in general more accessible to the mere mortal IT administrator who's not a DevOps professional per se,
Right.
but now they can participate in this conversation?
Right. Absolutely. Right. So I think low code, no code is solving two problems. One is that in general, what does any low code, no code solution do? Right. It's trying to abstract things and trying to democratize the technology so that more people can use it, whether it is website design with Wix or mobile development, or they're like tools like Unicorn and so on. So the exact same thing is done by in the DevOps space. On one hand, to developers, it's abstracting out the nuances of security, compliance, and operations. That's the value no code, low code is giving, because they already know coding. And then as for the DevOps people are concerned, it is actually abstracting out the complexities of writing tons of code, queuing it and reviewing it, maintaining it, and so on. So it's solving two problems to two different audiences. So in that sense, it is making DevOps and infrastructure accessible more to wider range of DevOps people and IT people, as well as developers.
So what do you think the impact of all this is going to be on our DevOps workflows? They were already kind of challenging to begin with, but now we got, theoretically at least, more cooks in the kitchen. So what should we be looking for here or thinking about as we think this all the way through?
Yeah, I think I would basically say that, one of the reasons why DevOps became so complicated is because there are just too many kitchens. So what does it mean? We adopted microservices. There are so many different pieces, all fragmented, moving around and stuff. And we had these just very few cooks who are running around from kitchen to kitchen and finding out, what is there, what is where, and trying to, cook things together, cook a soup over here, add it to the rice on that other kitchen, and so forth, right? So that is really what got us into a complicated situation. So now what is happening is that everybody has their own kitchen. Everybody has the tools that they need to manage, and they all sort of like operate independently, and they can operate their services and applications end to end. DevOps has an important role in terms of governance, in terms of even deployment, security, and a lot of these baseline configurations, while developers can own a lot more than what they are doing today beyond CI/CD and so forth, and be more independent. So I think it's a very happy medium where everybody's productive and nobody's sort of like worked out and stressed out.
All right, well, we got our first question, which I'm going to throw your way, and we're going to encourage you all to find the chat button in the Q&A. But our first question essentially is, we have somebody who says they work in both DevOps and low code, and they're kind of trying to figure out what their career roadmap looks like going forward. Is there patterns that you've seen where people are successful or among your best customers? What are people doing that gets them further down the path faster?
Yeah. Since you actually talked about career and future, I would basically say, we are all excited about low code and no code and which was actually a very big thing. And suddenly there is this absolutely phenomenal thing, which is around conversational AI, right? So I think since you're talking about career, so what is low code, no code, right? Is okay, it's telling you not to actually write code, and you can put together building blocks, whether it is in the UI or you can actually write less code. Conversational AI is about, like, you can just tell as if like I am telling Mike what I need. Mike, get me an environment which is enabled with Kubernetes. I want a RDS server and an S3 bucket combined together, right? You would probably see this going to another level wherein you could actually just tell a chatbot to do it, and the chatbot could probably use a low code infrastructure and so on. So I think I would basically say, honestly, a few months back, I would have given you a different answer, but right now I think you have to weigh in your options. Of course, coding is probably now old-fashioned, right? Too much coding is definitely old-fashioned. You have to look at these higher-level abstractions and sort of see where the industry is going with conversational AI and everything else.
All right. Well, now we have a follow-up question. So does that mean that prompt engineering is going to be used within DevOps and infrastructure as code, and we should all be figuring out how to use prompt engineering within our workflows?
I am not aware of this term. Like, what is prompt engineering?
Prompt engineering is the term that people are applying for querying ChatGPT and these other platforms to get them to tease out the best optimal answer that you're looking for from the platform, because the platform's general purpose. So people are kind of developing skills to tweak it out for specific use cases, which DevOps would be one.
I think I would basically say DevOps has two parts to it, or rather three parts to it. One is provisioning, other is debugging, and third is sort of like, so to speak, the security aspect of it. So I would say the immediate application of prompt engineering, the way you described it, is going to be in operations and debugging, basically, right? Hey, whatever so-and-so bought, I'm having this particular issue in this particular environment. Can you tell me what's going on? Right, and then we should be able to get the answers. And I'm sure all these infrastructure vendors are going to integrate their tools and train their systems on top of that to do that. So that's an immediate impact that's going to happen in regular mainstream operations, in security, debugging and stuff. And then I think maybe after that, people would start asking for deployments and updates and so forth.
All right. So we can expect that there'll be more people than ever provisioning infrastructure, building applications, deploying it. Are we all worried that DevOps is going to become something of a bottleneck because we're adding more to the front end, but it doesn't seem like we're changing the back end workflows all that much. So do we need to look at this whole thing on an end-to-end basis?
Yeah, I think I would sort of assume that when we are talking in the context of no code, low code, it actually has a very strong backend, which indeed solves the backend problem, and it just makes it easier for consumption using no code and low code. Like now, if I were to slightly switch to look at Duplo Cloud, right, which is what we have built, we really built an engine which fundamentally is meant to do DevOps as a service, right? So that DevOps doesn't become a bottleneck. It can be democratized to everybody, whether it is IT or engineering and so on. And then we put a low code, no code user interface to that. So I would say that a strong backend which provides DevOps as a service is a fundamental tenet to any low code, no code DevOps system.
So does that mean I shouldn't go build my own custom DevOps environment? Is there more something that feels like a platform as a service approach that I just kind of deploy and make use of rather than building out all these custom instances?
That's bound to happen, basically, right? So infrastructure was very complicated. Infrastructure as a service happened, and today we take it for granted and we call it cloud. DevOps is really complicated, right? And sooner or later, DevOps as a service will happen. I think the latest technology is just going to accelerate this substantially.
All right. You opened up the Pandora's box here, so we have another conversational AI question. And the question goes to the core of it is, how much will this take away the DevOps tasks that we do today? And I guess, the implicit question underneath that is, what happens to DevOps engineers?
No, I think I would say, it's a big threat to labor, right? I mean, there is no doubt about that. And I don't talk purely about DevOps or like maybe call center automation and so on. But I think what it will solve, whichever way you look at solve or create problems, is that it's going to first go after the rather harmless operations, basically, like for example debugging, for example, right? What's wrong in the system and stuff like that. So what definitely will happen is that if you suddenly need like 10 engineers to debug, monitor a system and find out what's wrong and operate on that, that sort of can be offloaded to a large extent to software, for example, right? And then we go from there. But again, I think we are talking about 2 to 5 year horizon, and what it can do. But if I were to be building a career in DevOps or any technology for that matter, I would try to go more on a higher level abstraction. And I think we should be watching this very carefully and clearly for over the next year to see where it goes. And people are going to an extent of saying that we have to put this to an halt until we actually have a better control. And these are people to the likes of Elon Musk and so forth. So yeah, we'll see. But I don't think DevOps tasks are going like just going to suddenly disappear in a year or so. But you'll find a lot of softwares which do magic, so to speak, right? Especially in debugging.
Do you think the things that will go away are essentially the things we don't like? I mean, there's a lot of toil in DevOps today and a lot of manual effort, and there's a lot of people who wind up doing things again and again and again, and they find it kind of boring. So, are the things that we don't like going to be the first things that get automated?
Yeah, I think I would tend to agree with that for sure. But then again, we also have to see that okay, there are people end of the day whose jobs are to do those things, right? I mean, if it is part of their job, just one part of their job which they don't like, obviously they're going to love it. But if that's what they do primarily, then we'll have to watch out for them.
Yeah. I don't think it's much of a secret, but a lot of the cybersecurity issues that we encounter, particularly in the cloud, are traced back to misconfigurations. A lot of the folks who configure these infrastructure as code deployments are not cybersecurity professionals. Many of them, the only cybersecurity they were exposed to was an elective during college, and they all skipped it.
Right.
So will low code, no code make it easier to not make a mistake and therefore, maybe accidentally leave, I don't know, a port open or something of that ilk? And, can we just get out of each other's way?
Yeah, I think that's the fundamental promise of any low-code, no-code technology, right? So what is it trying to do? It's trying to abstract things away from you, and it is trying to help you not make mistakes, right? So like, for example, when we built a low-code, no-code DevOps, the fundamental promise that we try to make is that, look, if you use this infrastructure, these set of compliance controls are going to be met by default, right? I mean, your databases would be encrypted, your security groups would be locked down, we will install virus scanners and all that kind of stuff. So that's given, basically, right? So any low-code, no-code technology is bound to have an engine which implicitly takes care of things which are harder for consumers to sort of like work on.
So will the platform have a set of guardrails that are kind of built into it? And can I turn those guardrails up and down depending on, I don't know, maybe the skill level of developer or the vertical industry I'm in? Just how granular can I get?
Yeah, that's really the concept of personas or roles, right? Like, for example, in our world, like, for example, Duplo Cloud as a platform, if you see, there is an administrator, there is a user, there is a tenant user, there's a security user, and so on. And different people can operate at a different level. And then, I mean, end of the day, like, and there are like very varying capabilities. Like if you were to take a pure platform as a service, like for example, Heroku, right? So there you absolutely have no control over the lower level infrastructure. You basically operate on their constructs. Whereas like, for example, then you go into a platform, let's say like Duplo Cloud. So Duplo Cloud gives you all those capabilities on top of your Amazon or Azure or GCP account. So you can still go behind the scenes and pretty much control everything that you need to in your cloud provider. So I think it depends on the solution. So pretty much every solution should be able to give you different levels of control. Some are a lot more opinionated than others. But I think how we should start off is that public clouds are here to stay. we shouldn't probably be just abstracting them away completely. We should really look at it like digitizing the labor as against like hiding something in the lower level platform from the users, because otherwise sometimes they even lose value or they may get stuck and so forth.
We have another question that goes to the heart of the current debate around how to better secure our software supply chains. And the question is are the platforms that we're using to develop the applications under attack? So how do I secure a low code, no code environment from those types of attacks when everybody out there wants to compromise the developer's credential, right?
Right. So yeah, I think there are some rather standard practices. Like I think what you are also saying. Let's say, for example, I'll take our example, right? So we have a low code, no code DevOps platform that runs in a virtual machine, right? And that has access to your environment. I think that's what you're referring to. So how do I secure this particular system? Because if I compromise this system, my rest of the system sort of gets compromised. So what you do is that you take the system and put it behind a very traditional VPN protected by MFA. So on one hand, the platform by itself has single sign-on and all those kind of protection, but you can make it better using more traditional means, like put it behind a corporate VPN, which is already protected by your corporate identity and multi-factor auth and whatnot. So those are the ways to sort of like protecting it. In this particular case. But if it is something like a hosted no-code, low-code platform like Heroku and so on, the responsibility lies with the vendor to protect it.
All right, so you're gonna take that weight off everybody's shoulders and protect that environment for them. Is that what you're saying?
Right. I mean, I guess the context here was, okay, you have taken the weight of securing the lower level stuff, right? Which is all great. You have done all the right things. But what if you yourself get compromised, basically? And what we are saying is that, well, you don't have to trust us to protect ourselves. You can always protect us by putting something like a VPN on top of us.
Gotcha. Multi-layer
and protecting your cloud consoles or any other software.
Multi-layer security once again. We have another question that's kind of, so we're seeing a lot of talk about shifting left and low code enabling shifting left. And I guess the question goes is, how far will that go? Will we shift all the way left to so-called citizen developers, and will they get in the act? And how to kind of work those folks into a DevOps workflow, because they're not exactly trained developers and we're having enough issues as it is.
Yeah. So I think the shift left, again, it's a spectrum, right? So that's where the guardrails come, for example, right? I mean, and also depends on your size of the company, which industry you're operating and so forth. I think a good low code, no code platform should be one that gives you the ability to shift all the way to left. So in the sense that if you really have a very strong technical lead, they can basically operate at that level, and you can bring up the system pretty much with no subject matter expertise. So you can just start off all the way. But at the same time, it should give you enough guardrails that if you have to shift right a little bit, saying that some of the functions are really done maybe by some specified people with specified functions and guardrails, and then the rest could actually be more democratized and so forth. So the platform should be flexible, and this can be achieved by roles.
Do you think DevSecOps will become easier to implement because it is built more into the platform? And maybe one of our issues today is that we're kind of adding on these workflows to existing workflows onto something that wasn't really designed for that in the first place. So does DevSecOps become something easier to achieve because we have a more modern platform and it kind of goes hand in hand?
Yeah, I think that is true, right? I think the fundamental gripe that people have with infrastructure as a code is this problem of fragmentation. And then it's just like so many places your code is. I want to open one port in a data, let us say, to connect to a particular database. Now I have to suddenly make a change in such a big code base. I run a plan and then I find out there are like 5 other things which are drifted away. So now what do? I'm stuck. All that I wanted to do is open a port. So I think those complexities sort of will go away with this particular system, and it will make this easier. Because it gives you a lot more structure. And I would say overall, we talk about low code, no code with DevOps or a DevOps as a service and so on. I think I would say it'll serve us good if we just remember that this has been done before for a very similar technology, a layer below, which was infrastructure as a service. All the complexities that we today take for granted and which have gone away, like VRFs, VLANs, networking, routers, storage, vSAN, with infrastructure as a service all existed before, and IaaS just solved it, and today we take it for granted. And I tell you, 5 years from now, 10 years from now, we probably wouldn't be even having this conversation. Just like today, we don't talk about how to set up a vSAN or a WRF in a Cisco ecosystem. Right. So I think it's just another layer that's going to go on.
There were cars before catalytic converters and after is kind of what you're saying. Let's follow up on that a little bit more. What do you think the relationship between cybersecurity teams and development teams is going to be like going forward as this all comes together? Because, historically, security people kind of look at developers as the root cause of all their problems, and developers look at security people as something to be end run, and kind of you're getting in the way of me writing and deploying code. So, can those two cultures be bridged?
Yeah, in fact, like we have a whole blog which actually just discusses this. I'll probably put this in the Slack, in the chat bot. I think both of them have a fair point, right? And one of the reasons is because, see, developers want access so that they can move fast, and it's not unfair to make that ask, right? But security people will be dinged if they get compromised, right? The infrastructure. So how do you find a happy medium? Today, the problem is giving access to developers is really difficult, because in the way the current public cloud infrastructure is like you have to do so many policies, and you have to keep at it to basically sandbox people into a particular environment and make sure that they don't shoot themselves on the foot. So that's really the problem. And it's not so much about the people saying that, okay, because both of them have fair in their ask. So the way I would say that this gets sorted out is by using software, right? The software should be able to understand. You should be able to create sandboxes in the software, assign developers to sandboxes. The software should automatically do just-in-time access, just-in-time permission. Like today, we have solved the single sign-on problem in the sense that, okay, you can integrate with your Google Office 365 and log in. The password problem is gone away. But the permission problem is still there, basically, right? So how do you know how much the permissioning would be? So we need to get into just-in-time permissions, and really having this low-code, no-code software layer, federating this between engineering teams and cloud providers should probably solve this problem. But access is probably the root of this the situation, and permissions, and we need to solve this. And it will be solved, and it is solved with no-code, low-code platforms.
In a similar vein, we've also seen the emergence of platform engineering teams. And when you peel that back, it seems like it's an effort by IT organizations to centralize DevOps services a little bit more and not have all these multiple instances of everything in every little group. Does this move towards a low-code DevOps environment facilitate that? And is that part of the reason to be looking at this? And what are you hearing from folks about platform engineering?
I think platform engineering is basically nothing but an in-house effort to build a low-code, no-code platform, basically, right? So they may not go to an extent of building a no-code, because that requires tremendous amount of effort in UI and everything. But essentially what they're all trying to do is that, okay, let me create a pipeline wherein you can enter like 4 or 5 parameters, and it automatically does like 10 things and so forth. So yeah, centralizing the DevOps function, creating self-service for engineers, democratizing it, DevOps as a service. These are all like goals of platform engineering. And the user interface for that ought to be something simpler than what is already. So obviously it leads us to low code. Now, if these teams are handy enough with respect to UI development, they'll also build no code. But I guess the main question is that, does everybody have to do this? Right? There are probably thousands of companies which are actually trying to do the same thing repeatedly in-house. Can you just go and buy a software, or can an ISV vendor go and solve this problem? Most likely, I mean, when a problem is so prevalent and it's solved by so many people, the Silicon Valley produces a software which goes and solves that problem. So, or someone else goes and produces a software that goes and solves this problem. And I think that's where eventually we'll head to.
How do I strike a balance between that centralization effort and the desire of every developer out there that wants to, I found the new tool and I got a new shiny object and I want to go use it, and I don't want someone to tell me I can't. So how do I kind of strike a balance between those two?
I think the way you can do the balance is that you can sort of like draw boundaries on what layers you can bring in a tool and what layers you cannot bring in a tool. Like, for example, if you're a developer, you want to, like, let's say, create a microservice, let's say to the likes of Kafka, which allows you to do better PubSub. Or, for example, it gives you a software which allows you to train your models better, run inferences better. I think that's all a fair game. A platform team should give them a platform where they should be able to create these services and operate on that. On the other hand, if the developers, or typically they won't, right? I mean, they wouldn't come and say, okay, I want to use this security tool to actually watch out for attacks on the networking layer. That would probably be out of bounds for them, because that's the job of the platform teams to operate it and so forth. So I would say that I think things that, and then further what they can actually do is that they should always have this capability of doing things in lower environments and stuff, and after a certain approval and a review process and whatnot, the platform should be such that it allows them to promote the same thing to production as well. So I think as long as the platform stops them from doing bad things, the developer should have the capability and the freedom to try things that they need to.
Do you think this whole move towards microservices and cloud native and containers is kind of forcing this conversation a little bit? Because that stuff is hard, and we've seen folks kind of go build that and then retreat, and then part of it just may be that the tools are a little too low level. So are you part of a movement to kind of provide a higher level of abstraction for helping to build and deploy those types of applications? Because right now it seems pretty hard.
Yeah, I mean, that's the number one reason why DevOps is hard. It's basically because of microservices. It's rather ironical. We wanted to do microservices because we really wanted to move fast, like not break things all over the place, like have modularity and stuff like that, right? And that's what like Amazon's SOA architecture, service-oriented architecture, was all about. But what people really forgot is that while Amazon had the SOA, they had a brilliant DevOps platform underneath it, basically, right? Which is not exposed to mainstream IT. They had everything automated that a handful of engineers could run millions of workloads. And that's why DevOps became so complex. People adopted microservices, but they didn't have the tools for DevOps, right? So I think that's the root cause of a lot of our problems today: over fragmentation and microservices and DevOps problems, I'm saying. Like, I mean, otherwise they're great, but bringing in a DevOps a tooling, low code, no code, fundamentally solves this problem. Kubernetes has done a great service of solving that problem to a large extent, but that solves it more at a container level, a container load balancer, service discovery and stuff. But all the lower level stuff, dealing with various different platform services from Amazon, security groups and stuff, that's a lower level function. And again, I go back to Duplo Cloud. And at Duplo Cloud, we have solved this holistically. We have incorporated security, Kubernetes, we have incorporated all the various other tools, and sort of like made this overall problem much easier. So if you check that out, it'll sort of be see how this solves it.
Going back to our earlier conversation about platform engineering, we have a question about how does all this work in the context of an enterprise application environment where there are so many integrations with third-party tools and there's lots of dependencies. So how do you kind of keep track of all the dependencies and relationships between all these things?
Yeah, I think, I would basically go back to everybody has their custom environment. So we'll probably have to sort of see how this is done. But maybe because I don't know the details of those integrations. But at a high level, I'll put it this way, right? When you adopt microservices and containers, there are so many complexities to solve. And Kubernetes sort of gives you an ecosystem to sort of solve that, right? Terraform gives you some way of stitching these things together and so forth. So I think we'll have to basically go and look at the enterprise architecture and sort of like put them all together. And then maybe, for all you know, right, maybe you might have to get a little bit opinionated and tone down a bit on various different integrations where and when possible. I mean, end of the day, before infrastructure as a service, enterprises had all these tools. Like, there were like 100 tools to deal with networking, so many with VMware and storage and whatnot. A lot of them did go away. Right? I mean, a lot of the backup tools just disappeared when we went to public cloud, because public cloud just gave you inherent ways of doing backups and replication and so on. So the same thing will happen on the DevOps, no-code, low-code front as well. I mean, it will fundamentally solve the problem by you not having to use some of those tools. But in enterprises, it's really a hard, slow journey because tools are associated with people, their subject matter expertise, and so forth, right? So it's not that easy. The process part is harder.
All right. We have a follow-up question on the microservices front. Somebody wants to know, so does Duplo essentially let me generate an app that's based on a microservice architecture? And if so, to what degree, or what are we thinking about here?
So can you repeat the question, Mike?
Well, the question says, does the low code generated by Duplo is that
Uses a microservice architecture.
well, is the app that I'm creating based on a microservices architecture?
Does low code generated app uses? Oh, I see. So I think this particular question is not, so to speak, applied to Duplo or DevOps world, but this is a very pertinent question when you are talking about end user application, basically, right? So, like for example, if you are generating a mobile app and so on, I guess it depends on the on what tool you are using, and based on that, we'll have to see. But probably, I would imagine that there is some amount of microservices and high availability and replication which is built in inherently into the system. So I would imagine that there is some level of that, but how much, I think it depends. And why does a user even care? That would be another question that I would talk about. If they do, they probably don't expose the nuances for you, and so forth. But yeah, it depends on what you're trying to do.
Well, yeah, I've seen some low-code platforms that claim to generate an application based on a microservices architecture, but it's always in the eye of the beholder, I suspect. To the question I would have right now, so we're talking about higher levels of automation all the way through. Just how automated do you think things will ultimately get? I mean, am I going to be able to walk in and say, I want X, Y, and Z, bang, 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 and then I'm just going to either type it or verbally say, make it so, and it's just going to pop up and away we go?
Yeah, I don't know. I mean, I watch a lot of sci-fi movies. I mean, the future looks very interesting, right? I mean, I wish I had a movie in mind. But yeah, I mean, I think we are all watching these movies. So things is all, it feels like, I think everything just becomes conversational. All you need is your mouth.
There you go.
You almost never have to lift hands.
Right. Well, and some folks are saying that, we built all these tools to create a way to speak to machines, and now the machines can speak to us. So maybe we don't need as much of those types of tools. So,
But I think end of the day, conversational interface is like another interface, and that probably is a next evolution of a low code, no code user interface. But the engine that goes behind the low code, no code, those abstractions and everything, they still remain the same abstraction that are being used by the conversational interface. Basically, right? So it's really your conversational interface, then you have the low code, no code, and then you have the engine. The engine doesn't go anywhere because you still need the engine, at least in today's technology. Basically, right? So conversational AI sort of like makes better use of that engine, and in some senses skips the no code, low code layer.
Right. In the land of digital transformation, one of the buzzwords of the day is hyper automation. Do you think that this is all, part and parcel of that larger shift towards what they're calling hyper automation, where we are automating at an unprecedented level of scale because we don't need to be as tied up about all the individual dependencies and pieces?
Yeah, I think from my experience, what I have seen is that automation at an enterprise is 50% or less about tools and technology, and it's 50% of more about people and processes, basically, because fundamentally automation at an enterprise level creates a sort of like, or rather exposes inefficiencies in terms of labor. Right, and that's where I think people sort of like push back and so forth, and that's what needs to sort of like get sorted out. Some enterprises have great leaders who sort of like manage it themselves. Some just learn it the hard way when their competitor sort of like takes over and stuff like that. But yeah, I mean, like, I think like I've heard of this analogy, like Hilton was forced to move to public cloud when they saw that Airbnb became like one of the biggest in their space without owning any real estate at all, or with all of their infrastructure purely basically run in public clouds and so forth. Right? Sometimes things are forced, sometimes people just change. But that's where I think the main impact of how hyper automation is going to be in people and processes.
We have a question going back to the citizen developers. How do we kind of maintain some sort of control and visibility of what they're up to? Because a lot of times they are completely bypassing the DevOps workflow altogether. So how do we kind of encourage this behavior, but not necessarily drive all the risks associated with shadow IT over the years? Got any advice?
Yeah. Oh, yeah. I think any tool that they should give, right? I mean, they're not supposed to give an overarching permissions for people to do whatever they need to do. Guardrails are very important. In every tool, they're like boatloads of guardrails that are typically built in. Like, for example, let's say in our platform, you can create sandbox for citizen developers and then basically put a quota, and they can basically not do beyond something. For example, that can be that can be more into so the pricing and the resources, or it can also be more in terms of security. Okay, they cannot create databases on public internet or expose public endpoints and stuff like that, or if they need public endpoints, they need to come to developers, DevOps engineers, and so on. So I think the way we should look at it is that today the reason why when people are given responsibilities they bypass DevOps is because based on current tools there is not a very clean, easy way of giving them limited access. It's pretty hard, right? Figuring out all the policies and everything. But if you have a platform in place, that will do this function implicitly.
And one of the things you will encounter over time is people who build low-code apps. It tends to work fairly well in a department, but then you try to scale that up in an enterprise, and suddenly, a lot of the things that a citizen developer doesn't appreciate in the way of software architecture start to manifest themselves, and there's a lot of bottlenecks and things that go into that. So maybe it just comes down to picking the right tool in the first place.
Yeah, I've always believed that I think when it comes to enterprise, it's more about people and processes, basically, right? I think the tools are there. I mean, if it works for a smaller organization and it doesn't work for a larger organization, why? What's the main difference? The difference is there are more number of people there, right? So more people, more opinionated, more processes, and so on. So yeah, the tools can solve the problem, but then we also have to remember while the proof solves a particular problem for an enterprise, it is also eliminating a certain job function, basically, who are supposed to go and do that. And that's what I see as a challenge in larger enterprises, like that transformation.
What is that one thing that you see DevOps teams doing today that just makes you shake your head and go, we're better than that, folks. We've been doing that the same way for the last 2 decades, and maybe we can just move on?
Basically basically having a sort of like sometimes have an attitude that everything needs to go through them, right? And developers basically should be cutting tickets and then telling them on what to do. That's like one that comes to mind at the top. And the second thing is that, which is my favorite, is every DevOps engineer thinks that everything is automated, but but then when it comes to developer, they're just waiting behind tickets. I think they have to recognize that what we call as today's DevOps automation is meant for the consumption of DevOps engineers. It makes them efficient, right? All the infrastructure coders and everything. It is not really for the consumptions of developers. That's a different level. So saying that everything is automated as an engineer or as a developer makes no sense when I have to wait and cut tickets for an engineer to go and get stuff done for me.
All right. This next question is a little philosophical, but I'm going to try it anyway. But what is the impact on product processes and product development? And I guess one of the issues that has come up recently is for years and years, everybody complained that the IT was too slow for the business. Are we getting to a point where DevOps is faster than the business can absorb, and the way that products are developed and brought to market that are software dependent needs to change as well? And it's kind of the big question of the day, but it goes beyond just the DevOps and IT folks. It's all about, how does the rest of the business respond?
Yeah, I think it's like this. There are a few things which make the overall process, right? So for a period of time, DevOps actually was faster, right? When we didn't have like that much fragmentation, IaaS was at its infancy, infrastructure as a code was new, and things were great because it was really making that level of technology faster. But today, with so many different moving pieces, DevOps fallen short. Infrastructure as a code has fallen short, basically, right? So I think the first thing is that's that. So we have to find a way to give control to development teams so that they can build the product faster. Now, in terms of the product development itself, I think we will build better product, faster product if we are able to leverage uh, services that are meant to do this. Like Amazon comes up with so many new services and innovations in terms of the product space, right? You have your managed Kafkas and managed Elasticsearch and trainings and SageMakers and EMR and whatnot, and you could use that and really make the product so much better. But you won't be able to get to that if DevOps cannot figure out how to actually provision them, and they don't give you access to provision them, right? So I think what I would say is that in the product space, tremendous amount of innovation is happening, and the cloud providers are fundamentally focused on that. We have to support that initiative through a more DevOps pipeline, modern DevOps pipeline.
All right. Well, DevOps is going to teach the business, I guess, how to run a process and kind of build something, and one will learn from the other. The tail will wag the dog, I guess. We have a question about are there integrations between what you guys are doing with low code and Azure DevOps services specifically? And from your perspective, are applications built using low code tools, especially ones in microservices, are they more secure, less secure, or differently secure than other applications? What's your sense of, are they?
Low code, the promise of any low code, no code infrastructure, low code, no code DevOps tool is that they inherently have to be more secure, basically, right? Because they have an opportunity wherein things are going through that particular workflow, and their job and responsibility is to abstract things away. So in that sense, as part of those abstractions, they have to abstractions or automation, whatever you might want to call them, they're supposed to secure things, they're supposed to put guardrails and so forth. So that's that, right? And the other thing is that, like, for example, they're asking, like, how does do integrations with Azure DevOps services? Like, for example, specifically in case of Duplo Cloud, Azure DevOps is a CI/CD orchestrator, which allows you to build various different types of pipelines. And that would basically call into the low code, no code system like a Duplo Cloud and basically drive the system. So the amount of code that you have to write inside your Azure DevOps, like Terraform and whatnot, sort of is substantially reduced. But you still continue to use your Azure DevOps and other CI/CD tools that you want to use.
We, of course, hear a lot about multi-cloud computing environments. Do you think we'll be building applications that span multiple clouds, or are we just going to kind of lean on one cloud primarily and then call out through APIs to some other service? But, the code that I build is going to be primarily in one spot.
Yeah, till about like 5 years or so back, 5-7 years, everybody wanted to do multi-cloud because people treated cloud as basically metal, storage, compute, network. It's the same everywhere else and so forth. But I would say I think that era has passed, and Amazon, Azure, GCP, they have done so much work in platform services by building core, custom, proprietary platforms, which are helping people get their product way faster, basically. Right. So as part of that value that they've given us, they've also created platform lock-in. Right. So trying to do multi-cloud in some senses is trying to swim upstream. Right. And sort of like, because once your developers have written code for a particular platform services dependency, it's pretty hard to break it.
All right. We got multiple questions pouring in now, so I'm going to drop into them as best I can. The first one seems to suggest that low-code apps are slower than because of maybe the middleware and the database dependencies and things slow down dramatically. So is that true, or is that maybe something that people perceive, but it has nothing to do with low code? What's
But at least I think in the DevOps space, infrastructure as a code space, I mean, fundamentally low code, no code platforms are faster. And I'll tell you why. Because infrastructure as a code is a client-based system. It runs in a sequence in one shot. Like when you run Terraform, plan, apply, it's basically doing one after the other in a person's laptop. Whereas when you actually have a platform, what you do is that you just give the intent to the platform saying that I want this environment to be done. And the platform, because it is running on the server side, it has the ability to do threads, locks, concurrencies, multiprocessing and whatnot, and it can span out and get things done faster. So at least, so I think is this what you said about its slowness being true is true in a lot of other areas. But in this particular space, in the DevOps world, given where we are with respect to infrastructure as a code and how that technique works, it's basically a script. It's an attended script, right? Anything will be faster than an attended script if you build it as a platform.
All right. Next question is Terraform still part of this equation, or did we just eliminate the need for Terraform altogether if we went
low code? The way to do low code. So what we did is that in our case, we actually wrote an SDK, or we call it a provider in Terraform, and created custom resources. So Terraform is still the language, low code language. So you don't have to go and learn like another brand new language like a Node or a Python or something else. You just keep using Terraform, but you just have to write a lot lesser code.
All right. And then we have a question about integration with AI services. Do you think that with the low code platform, I'll just be invoking, I don't know, ChatGPT or some other service within my application, but that will all be handled within the low code environment? What's your thought about, and this has nothing to do with low code in general, or specifically, but in general, what's your sense of how we're going to...
So if you were to create a stack, right, the bottom of the stack are your infrastructure providers like Amazon and so forth. On top of that is your platform, which has the engine and the abstractions to sort of figure out how to program that given an intent, right? On top of that, this is what we call it as the DevOps platform, or like platform engineering and so on. That platform exposes itself via, let's say, a low-code interface, an API interface, and a no-code interface today, right? That's what we were talking about. AI is a layer on top, basically. The AI probably uses either the low-code or the APIs that are exposed by the DevOps platform that eventually goes and programs the system. So I'm talking about conversational AI, by the way. Right. So if this question was in that context, so you would probably be talking to conversational AI and not consuming the low code, no code as much.
Otherwise, you're calling something as an API as you would anything else in the world, and it's kind of similar in construct because you don't really need to know the AI model underneath it if you're just using the API, right?
Yeah, but there's another thing. But if you're not really talking about AI in a conversational context, you're just talking about, okay, can I use AI to sort of like figure out what are the things that are going wrong in my system? What are the security alerts that can happen and so forth? Yes, then in that case, AI is a lower layer, basically. So you still have your low code, no code system that is invoking all these AI services underneath it to actually bring a particular individual value to the user. So nowadays, whenever someone says AI, it sort of becomes, people assume that you're talking about conversational or generative. But in this case, I think, yeah, if you're talking about models and like other value-added AI services, that would go underneath the low-code, no-code platform as plugins.
Okay, we have another Terraform-related question, which is more specific, but do I need to know Terraform and learn that, or can I skip that altogether and just kind of invoke it through your platform?
That's the no-code approach, right? So either you can use no-code, so no programming language, anything needed, just go to the UI and use that. Or if you want to use Terraform, of course, you can use that. So, it's you can use whatever that you like.
All right. So what's your best advice to folks right now where we are? It feels like we're on some sort of continuum and various folks are at different places in that journey, but what's your advice to them in terms of making this next transition? What have you seen your customers do well?
I think overall, I would basically say that I would push myself more to align more towards as a service offerings, basically, right? Anything which takes time where people are waiting on you is not going to last very long. effectively, right? So as you think through whether you are working in an organization, how to make that better, or whether you are thinking in terms of your own career or in where I should be focused and so forth. So I would basically go and align myself more towards higher and higher in terms of abstraction in the stack, basically, right? I would rather go up the stack than try to go down the stack. And that may actually fundamentally mean that I have to give up some of my core skill set and learn new ones. But hey, you know what? I mean, that's what we all do as individuals and humans and software engineers.
Do you think to a certain degree we may have inadvertently identified ourselves too closely with a particular tool or platform, so people consider themselves to be a Jenkins person or a GitLab person, and maybe, you know, folks need to kind of take a step back and say it's not necessarily about the particular instance of the platform as much as it is kind of like, here's the goal and the mission, and the tools are kind of the means to an end?
I think it depends on what's the scope of that particular platform. Like, end of the day, I mean, we have all just picked up a cloud, right? I mean, like, we are all an Amazon shop or an Azure shop, GCP shop, an on-prem shop, and so forth, right? And that's like a decision. So the broader the platform is, the more people have to be on board with that, right? And the more the people would care about that and so forth. But on the other hand, if it's like really a narrow tool, like for example, I decide to use a certain version of a Mac terminal in my laptop. I mean, nobody cares, right? What I do, it's mine. Then the next level is that, okay, I've picked up Jenkins versus GitLab. Okay, more people care about that, right? Because, you know, they have to use it and so forth. Oh, then I use infrastructure as a code. Maybe only your DevOps team cares about. But I use Amazon, and I suddenly tomorrow go and tell people, hey, you need to move to Azure or vice versa. People are going to throw a fit. That won't even happen, for example. Right. So it really depends. We all identify ourselves with tools. It depends on the scope of it. If it's smaller scope, it's easier. But if it's a larger scope, you need to drive consensus.
All right. Last question. Is the pace of application development going to accelerate? Will it get too fast for us to keep up with? And, you know, what's your sense of what will be the pace of application development going forward?
Yeah, I think if machines are writing code, for sure, right? I mean, like we were writing code to build machines, and now it looks like machines are writing code to build themselves, right? So yeah, I think things are going to go at a crazy speed.
All right, folks, you heard it here. It's a brave new world, so buckle up because things are changing. I think with that, I'm going to hand it back to Cody, and he's going to take us out. And also, before you go, make sure you check out all those handouts on the top right there.
Awesome. Venkat, thank you so much for joining us today. And Mike, thank you for leading us through this past hour of discussion.
Thank you, Cody. Thank you, Mike. Thanks, everyone.
Of course.
Right. And of course, I can be reached out at LinkedIn, and my email is venkat@duplocloud.net.
Awesome. Awesome. Thank you so much. So again, thank you both. I'd like to remind everyone that this session was recorded. Should you want to rewatch this, or perhaps that you've had such a great time you want to share it along with some people you know, you can do so. You will be receiving a link to access the on-demand via email, or you can also find this recording living on the DevOps website at devops.com/webinars, and then be sure to look in the on-demand section. It will be there waiting for you in just a couple hours. The 4 winners of our $25 Amazon gift card are Renee C., Suraj P., Oliver M., and Toel T. So to our 4 winners, congratulations. Keep an eye on your inbox to claim your gift card. It should make its way to you in about the next 48 hours, but if you don't happen to see that email, do check your spam folder. We do also have a survey that will pop up on your screen as soon as we close out. So tell us what you thought about our program today, or if you have anything in mind you'd like to see on a future program, go ahead and send in those suggestions there. And of course, I would like to thank Duplo Cloud for bringing Venkat on with us today for this conversation. So to everyone, thank you so much for being here. I'll let you all disconnect. Hope to see everyone at a future Techstrong learning experience.
Thank you.